Okay, so impulse is the physics word that we use for change in momentum.
You started too quickly.
Okay, so impulse is change in momentum, and although we know that in a collision, the total momentum of the system like the bodies involved in that collision, remains constant, the individual momentum of each one of the bodies does change. And so we can calculate the change in momentum of any body involved in the collision by just doing final momentum minus initial momentum. The other equation that we've got at our disposal for momentum is that the impulse, the change in momentum, is equal to the force times the time that that force acts for, like the duration of the collision. And this equation here is really useful for understanding like harm or damage in the collision. The thing that hurts people and breaks things in collisions is the force. Like the harder you push something, the more likely it is to break. And so when we have a collision, we're usually moving along at a constant speed. We've got a fixed amount of momentum. So if we're going to drive our car into a wall, we've got a fixed amount of momentum that we have to get rid of. The thing that's going to harm us is the force that acts. And so what we need to do in order to reduce the harm in a collision is increase the duration of the collision. We see different technologies for increasing the duration of the collision, all sorts of places. Who's got an example of a technology that increases the duration of a collision?
Crumple zone in a car.
Crumple zone in a car.
Gloves.
Wearing gloves if you're catching a ball. What else?
Would springs work?
Football boots.
Football boots. What do they do?
I don't know, that's what you're talking about, like change make it longer or something.
They've got some cushioning in them.
A
Maybe
trampoline.
kick the ball.
Trampoline.
Yeah, so jumping, like you can be really high up and jump down and land on a trampoline, and because it takes a while to slow down, that's way less painful
And
than
a
jumping
bungee jump.
onto the ground. And a bungee jump, right?
Springs.
Climbing ropes are dynamic ropes. They're designed to stretch when you fall on them. If you had a static rope and you fell on a static rope, it would break you.
So that's
because-
why it's so bad if you fall on a caving rope.
That's why it's so bad if you fall on a caving rope, because they're static ropes. Exactly.
Like on the ground, but on your groin.
So lots of sports equipment we're going to see designed to reduce the force by increasing the time it takes for whatever collision to happen. That's what protective equipment does. Happy?
Yes.
Good.
Do you have anything else to write now?
No.
Damn it.
But I can if you want me to.
No, it's fine. I'll
I
wait.
can write that by increasing the duration of the collision. Do you want me to write it?
No, it's so boring.
Do you want to?
Oh.
Well, I won't write it then.
Okay, don't.
Get someone else to write it.
You can stop the video.
Can I write it?
Go on.
Hell yeah. I have to do it from this one though. Oh my god, no one will be able to read it.